Fellas, last day. You can do it. This is assignment A12, and we are using right triangle trigonometry to find the missing angles. Okay, so same thing, just a little different. So I'm going to give you my view of my screen. Sorry, I'm happy. Okay, so here we go. Here is a right triangle. Remember the trigonometry we're doing is only for right triangles right now. And we have to ask ourselves, they want us to find this angle theta, and we're right away back to this SOHCAHTOA deal. In relation to that angle theta, what do you have? Do you have opposites? Do you have adjacents? Do you have hypotenuses? Remember, hypotenuse is always the side opposite the right angle, so we have a hypotenuse. And we don't have an opposite, we have an adjacent. So that suggests the cosine relationship. So I'm going to write that the cosine of this angle theta is equal to 13 over 17. So remember that when you did that demonstration with the Desmos the other day, the point was to encourage you that as long as triangles have similar shapes, the side lengths are going to be the same relationship no matter how big or small those triangles are. So we use that. We're going to ask the calculator to find the angle that has a relationship of 13 to 17. And the calculator doesn't have a bunch of crazy things stored in it. It has a way of finding these things for us. So, and we learn how to do that in calculus, by the way. So what we're going to do is we're going to ask the computers to say that our angle theta is equal to the inverse cosine, and it's going to look like cosine raised to the -1, but that's not what it means. And we're going to say, what is the inverse cosine of 13 to 17? 13 over 17. Remember, before we knew an angle and we asked the calculator to give us the side length relationship. Now we have the side length relationship, so we're doing the inverse of that. In Algebra 2 next year, we're going to talk a lot about inverse functions and what those mean. But remember that addition and subtraction are sort of inverses, right? If you add 3 to 5, you get 8. And if you turn around and subtract 3, you get 5. We end up right where we started. So inverses enable us to kind of go back and forth between things. Okay, so first I'm going to start with the Google calculator. And remember that we have to be in degrees. And I'm going to hit this little inverse button. And now this sign of raised to the -1 pops up. That's what it looks like. We want the cosine of 13 divided by 17. So we're going to say, what angle is that? And it says it's a 40.1 degree angle. I'm going to say it's approximately 40.1 degrees. And I can see that makes sense. That seems about right. Remember, use your number sense. Does your answer seem appropriate? That answer seems appropriate. So approximately 40.1 degrees. Just as we studied similar triangles, the only ones that are going to give you exact degrees are those relationships that happen to lie in 30, 60, 90 triangles, or yeah, in 45, 45, 90, such as 1 and 1/2 and the square root of 3 over 2 and things like that. Okay, Summit knows what I'm talking about, don't you, buddy? Okay, let's do another one. Ooh. Here we have an angle that we want to find, and we have an opposite and a hypotenuse. Opposite and hypotenuse is the sine. You just write it down each time if you need to. The sine of a certain angle theta is 2 over 5. So we are going to say that theta then is approximately, it's exactly equal to the inverse, the inverse sine of 2 over 5. But it is going to be an approximate value once we put it in that calculator. So let's go back to our Google calculator and do inverse sine of 2 divided by 5. And what do we get here? 23.6, approximately 23.6 degrees. Okay, GeoGebra? GeoGebra uses the command arc, just like Google Calculator. When I put inverse sine, an arc popped up. So I type in arc cosine. So here we have an arc cosine with a D and an arc cosine by itself. The arc cosine by itself is going to give you a radian measure. This one's going to give you it in degrees. So 2 divided by 5, I'm going to hit enter, and I get approximately, uh-oh, why did it do that? Let me try. Let's see, maybe I was in the wrong thing on GeoGebra. No, I'm in degrees here. And so you see that I have problems too. And I don't stop when I have problems and ask somebody. I just try to figure it out. So I'm going to do arc sine. Did I do the wrong one? Maybe arc sine of 2 over 5. Maybe I did cosine. I did. I did the cosine. So approximately 23.58. You guys noticed what I did wrong, I hope. Okay, so back to this again. See what I did here? We had an opposite and a hypotenuse. So I said, that's SOHCAHTOA OH, opposite over hypotenuse. And then I went to the calculator. One more. Yeah, finally they stayed where they belong. That one's almost perfect. Okay, 7 and 14. You guys are really, you guys are really good at pattern recognition, so you know what one I'm going to do now. I have an opposite and adjacent. This is TOA, this is tangent. So I say that the tangent of my angle theta is equal to opposite over adjacent. That one happens to be 2, so I'm going to say that theta then is equal to the inverse tangent of 2. Okay, I'm going to put that into the calculator. I will do it first with GeoGebra, and I'm going to write arc tan, and remember, there's a couple of them there. I want the one with the D because I want degrees. So arc tan of 2, 63.43 degrees approximately. 63.43 degrees. On the Google calculator, we have inverse tan of 2. And there we go, 63.43 degrees. If I entered that when I had radians, I would get 1. And so hopefully when you look at this picture, you say, okay, that angle cannot be 1 degrees, right? And so if the opposite is greater than the adjacent, it has to be greater than 45 degrees, right? So use your number sense. Remember, though, that's not going to be foolproof. That first example I did yesterday, I said, radians and degrees were really close. So make sure that you are in degrees. Simple as that. I'm going to give you an assignment, and I don't know how many I want you to do for this one. I will let you know in the instructions. So last assignment. You are there. It's a great day to be a Bruin, and I love you guys. Bye.